Good morning, everyone, and we're delighted to have you for the second of CITA's online regional week. My name is Suzanne Purcell, and I am General Manager for CITA. I just wanted to quickly bring you through this week. Obviously, there are 5 events taking place from 12:30 until 2. And there are different presenters on each day, all depending on which region they're from, and some people are crossing over the region. So we've a great selection of different speakers from the different regions, from companies and from academia. So I hope you enjoy the full week taking place this week. And then for those of you who are new to CITA or it's your first CITA event, just to give you a synopsis really of what CITA is. CITA is a not-for-profit organisation. We've been in existence now for nearly 20 years. And there are various different offerings when you become a member of CITA. You can avail of the 30% CITA SkillNet funding. You can have your company's profile promoted on the CITA.ie website, where you have the Tech Trend series and the regional events. And you also get a membership rate to attend the CITA BIM gathering. So one of the series that we run is the Ask You event series. So we've had 2 of these events already taking place. The 3rd event is coming up there on the 6th of May. Then we have the Technology Trends series, which also has 10 events in it. 2 of these have already run. The next event is the 22nd of April. We have the CITA SkillNet training network, which is in existence since 2008. And it is got a huge amount of diverse courses, construction specific courses, and that, which you are more than welcome to go onto the CITA website and have a look at that. The gathering is the 5th CITA BIM gathering, which we're delighted is going to be presented or taking place in September. And we've now changed it from the 21st to the 23rd. So it's just going to be a 3-day event, longer days instead of just 5 lunchtimes. There are 10 different categories. We have already received 42 abstracts, which is great. It's an increase on 2 years ago. So that's going to be running from 8:30 until 1:30 on the Tuesday, Wednesday and Thursday of that week. And that'll all be virtual. So if you aren't already connected in with CITA, make sure to check out the CITA website. You can go on to the past event pages, the training pages, the membership pages, the sponsorship pages. You can also then connect with us on all the social media platforms, Twitter, LinkedIn, YouTube, Facebook. Any questions, get in touch with the CITA team and admin@cita.ie. And don't forget to subscribe to the CITA YouTube channel. And that's where you will hear about all the new videos being uploaded from events like this. So I hope you enjoy the event, and I'm going to hand you over to Andy McNamara now. Thanks a million. Shannon, do you need to unmute Andy?
No, I think Andy's just needs
folks, just sharing my screen now.
Thanks, Andy.
Hi folks, I hope you're all very well. Welcome to the first of this week's CITA's regional events in Galway. So we've some good speakers for you here today. We have Padraic King and Jaime Mulcair. So Padraic is Design Manager of King and Moffatt Building Services. He's going to be talking you through the use of BIM to facilitate modular and offsite MEP installations. Jaime is BIM Manager with Roadbridge, and he's going to talk about BIM for civil contractors. So they're going to show how they're using BIM in a real world context to help them and help their companies to work better, in a better way. I just ask, if you do have any questions, if you could put them in the chat box and we will get to them after the meeting, if that's okay. Just a bit about myself. My name is Andy McNamara. I'm a lecturer here in GMIT. I started here in 2016. Prior to that, I actually studied architectural technology in GMIT before doing a master's in engineering and science in IT, in architecture, engineering and construction in UCC. So I've been working in BIM since I left college before coming into academia. Before I start, I'd just like to announce, I'm delighted to announce that GMIT has become Unreal Engine's first academic partner in the Republic of Ireland for our use with Twinmotion and Unreal Engine. So Twinmotion is it's a render engine. So we use it to create renders and videos of BIM models and buildings we're using. We're also beginning to branch out into using Unreal Engine, which is a game design engine. Most of you might know Fortnite. Fortnite was designed using Unreal Engine. So we're starting to look at that. As are many other architects around the world, like the Zaha Hadid architects and big architects are using Unreal Engine to aid in their design process. So we're delighted to announce that we're the first academic partners in the Republic of Ireland. So I was going to go talk about a small bit about some of the challenges that we faced at the college over the past year, that we've faced, and more so the students have faced. So we've all had to make some changes recently. I just want to talk about how the students have gotten around this and how, as a college, we kind of helped them to push through it. We have the usual problems of broadband that I suppose in parts of the country we can't do much about. Even though those services have been improved recently. But from a hardware point of view, the college has gone to great lengths to ensure students do have the correct hardware. They set up a laptop rental scheme, which is brilliant. They've also set up remote access into all the CAD labs, so students can access the high-end computers in the CAD labs remotely from their own home, which is brilliant. Software has been a small bit of a challenge too. There's been just even with different versions of software, students having the wrong versions on laptops. But again, it's something we can get over pretty easily, but it can be an issue at the beginning. The main thing I think is different with them is the fact that there's a lack of in-person feedback. There's nobody walking around the room. If they're designing a building or modeling up a building, there's nobody walking around the room to help them. So I think they miss that feedback. So we've gotten around that by doing kind of one-to-one sessions with feedback, or else small breakout rooms with maybe 2 or 3 students and giving feedback that way. One of the other issues I've seen is just trying to keep students motivated. It's very difficult for them at the moment, as you can imagine. So we're trying to keep things as interesting and as fun as possible, I suppose, while meeting all the learning outcomes and everything. Typically around this year with my second years, I'd bring in a VR headset. They could walk around some of the buildings they're modeling in VR. Of course, that can't be done now. You can't be passing around the VR headset. But what we have done is things like group challenges. So this is just a sheet from one of the group challenges where they're working with IKEA for the day, and they produce a number of BIM components for IKEA. It's pretty interesting. It's a good way to get them to learn. They're put into groups. There's a bit of friendly competition between the groups as well. You know, the students really enjoy it. These are some of the components I had to model. Apart from that, we're using Microsoft Teams for pretty much all communication with the students. So this is some of the work that the 3rd and 4th years in architecture technology are doing at the moment with Jared Nicholson. So he actually has Moodle integrated into Teams. He also has BIM 360 docs linked up to the Microsoft Teams that they're using, which is pretty interesting. This is just some of the information from docs coming through in Microsoft Teams. So as I said, the 3rd and 4th year architecture technology students are using BIM 360 a lot at the moment. So prior to this, students would have uploaded their assignments to Moodle. Now they're actually working on shared models in the cloud and then issuing them on BIM 360 docs to be reviewed by the lecturer. The lecturer then gives us feedback through BIM 360 docs. So we can see here they're set up in multiple groups, as you will be in a real world project. They're working on a work shared model in the cloud. It's just some of the models they're working on. And then we're using the design collaboration package. I'm trying to make it as real world as possible for the students. So a lot of what's being done here has been done by Jared Nicholson with the 3rd and 4th year architectural technology students, using Autodesk Revit as the primary authoring tool. It's good for a number of reasons. I suppose it's the most widely used BIM authoring tool in Ireland at the minute. The licensing for students also helps from Autodesk. They get free license for it. This example is showing them working on collaborative projects where you have architectural, structural, and mechanical disciplines all working in one. What's also useful is that Revit 2022 has been announced. I'm sure some of you have seen. There's a couple of recent revisions to it that would be very useful to companies, but from the college, what it will be useful is the fact that it has a built-in PDF printer. We found that's a problem before with students using different PDF printers at home and different ones in the college and so on. That should help us sort that out. We've been also doing quite a bit of laser scanning with the students. This is actually a portion of GMIT, of our Galway campus on the Dublin Road. So they've been using the point cloud scans to model up the existing building and then eventually to build onto it. The 4th year architectural technology students go through the BIM approved graduate program. This is a formal recognition of competence in the BRE. It familiarises students with the principles of BIM and gives them a thorough understanding of the BIM process to cater for ISO 19650 standards, and leaves them ready for a career in the construction industry. This is pretty useful to students when they leave the college, as it is to their future employers. Once they've completed this, assuming they've passed all the sections in it, they can apply to become a BRE BIM certified individual without any more training. We're also busy planning for training for the World Skills competition. So Ireland has had some good successes recently in the World Skills in the digital construction category. So we're working at that and how we can train some of our students for that. That's just some of the work from the architectural technology students. So BIM and digital construction is taught throughout the entire building and civil wing in GMIT. So we have quantity surveyors, civil engineers, architectural technology, and so on, and construction management. But we also have the higher diploma in engineering in BIM. This is a multi-award winning program. We've been running it for a couple of years now. I'm sure some of you are familiar with it. It takes place over 2 years. Students learn BIM virtual modeling fundamentals first of all. So it's essentially an introduction to virtual modeling. Following that, they choose an elective depending on what their background or what their interests are. So we do BIM architecture, BIM structure, BIM infrastructure, BIM MEP, and we're soon to be adding a BIM for contractors section to that as well. So that should interest a lot of people. After that, they look at the BIM collaboration section where they go through the BIM accredited graduate program as well as working on group projects within a multidisciplinary environment. So it's with the engineers, mechanical teams put together, and architectural groups, and they all work together under one models using BIM 360 docs, Navisworks, Revit, Civil 3D, and so on. Following that, there's a 12-week research project. The student picks a topic related to BIM and carries out a research project on it. This program has been pretty successful to date. Both of our speakers today are actually graduates of this program, which is quite interesting. Padraic started, I think he was in the first group of students I taught in this program in 2016. And Jaime has done it a bit more recently to Padraic. Of course, everything that's happening is part of our BIM team, or it's down to our BIM team here at GMIT. So there's a great group of people there who are working on it. And we have some more exciting news soon that I'm sure you'll hear about from a BIM point of view, but we can talk about that again another time. Okay, so to finish up my section, I'm going to introduce Padraic King. He's going to talk about the use of BIM to facilitate modular and offsite MEP installations. So they're doing some pretty cool offsite construction and have been for the past few years. So I'll let Padraic fill you in that, but I think you'll find it enjoyable.
Thanks very much, Andy. Thanks for that. And that's great stuff you're doing over there in GMIT, getting the students using the BIM 360 common data environments, and even what you're doing on Teams. Like, it's great practice for the get into the office, I suppose. My name is Padraic King, and currently I'm the design manager with King and Moffatt Building Services, and I was the BIM manager from 2016 to 2019. And as Andy said, he was correct. 2016, I went back to college and did the HDIP in BIM. I had a big interest. I was doing a lot of CAD work and before that, and I had a huge interest in the BIM. So I started looking around to see where I could get a course on, and found that a course in GMIT was a huge help with Andy and the rest of the team there. BIM it's a huge driver towards offsite and modular construction within the company. I'd say without it, to be honest, we'd be extremely reluctant to take the chance, I suppose, on doing a lot of the work off-site. It's invaluable for early coordination and identifying issues before you run into them on site. I've successfully completed multiple large-scale BIM Level 2 M&E projects in Ireland and the UK and Europe over the last few years. So King & Moffatt, we're an international company, and we're currently on site in Ireland, the UK, Germany, and the Netherlands. And we're pricing a couple of projects now in the Nordic countries. We've fantastic clients, international clients like Amazon and Lidl and Hilton Foods. And our M&E team, they're familiar with all the local standards and regulations for the various countries and regions that we undertake any work. And just that map on the right-hand side, we've completed projects in all the areas there that are coloured in our navy blue, and we're targeting work in the countries there that are in orange. So the company, it's experienced massive growth in the last couple of years. One of the main reasons has been we have taken in a full mechanical division now. A lot of the years leading up to that, if we won an M&E package, we would have been subbing out the mechanical element. But now we have a full in-house mechanical team, site team, directors, designers, everyone. So the company turnover it's over doubled in the last couple of years. It's currently at around 130 million a year. So just a couple of locations that we have. Our headquarters is in Carrick-on-Shannon in the Midlands in Ireland, and we've got 4 offices in the UK. Birmingham and London, Stoke and Edinburgh. Stoke and Edinburgh would be primarily our mechanical offices, and Birmingham and London are primarily our electrical offices. And we have our German offices in Wurzburg, and in Holland we have an office in Amsterdam. So in the presentation there, Andy gave me the good news that I could take longer than 20 minutes, but I don't know if it was good news or not. So I've decided to talk about kind of why we got into it, and then go into some of the slides showing kind of some of the stuff we're doing to fill a bit of time up. So I'll just be talking about why we've invested heavily into it in the last couple of years, and how we're using BIM to streamline the process. And at the end, I'm just going to talk through some benefits that we realized from undertaking modular and offsite construction. So firstly, I'll talk about why we did it. So the majority of the company's turnover is outside of Ireland, and the company was originally set up in Ireland. But a huge amount of the workforce and our qualified employees reside in Ireland. So that was one reason. And I suppose the travel is costly, and this year it's proven to be quite difficult with COVID-19, this year and last year. So we've really decided to invest into it, because it was relatively easy to go over and back to the UK or over and back to Germany leading up until the pandemic. But some places in Germany now where it was a direct flight for maybe an hour and 30 minutes. Now some of the areas in Germany where we're working, you need to get 3 flights. So the pandemic has had a huge effect on traveling. So just on the right hand side there, like your carbon footprint there, when you're doing a lot of flying. And there's one interesting one there, is a car with 1 passenger. I know in the first lockdown, where there was construction sites open and there was a lot of uncertainty around COVID-19, people had to travel up to the sites or all around the country on their own in vehicles. So that's having one person in a van that might have 5 or 6 seats. It's it's just huge money wasting, and it's a huge effect it's having on your carbon footprint as well. So the more of that stuff that you can eliminate, the better off you'll be. So another thing we've really noticed, that delivery issues have been eliminated basically for any of the stuff you do off site. So what I mean by that is, you could order up stuff from wholesalers, and it mightn't arrive when it's supposed to arrive, and then the deliveries can be fragmented. So your ladder could arrive, your cable ladder might arrive on one truck, and your cable basket, say, or your cable tray, it mightn't land for a couple of days later. So you've different bits landing at different times. Whereas if you build everything, combine it all off-site, you're eliminating all these issues. Supports and brackets, they can arrive to site missing important fixings and accessories. And issues like these, the result in the employees having to return to the same location on a project multiple times to finish. So if they go and put up some hangers, that's a couple of guys going up in MEPs to put up the hangers. Then when the ladder arrives, they're going back to the same location to put up the ladder. And if there's a late delivery of cable basket, then they have to go back again. So you're visiting the same area multiple times to close it out. And then there could be an issue with getting items like end caps delivered to site. They're the yellow things on the right hand side on the image, which you have to put over the end of your supports there for safety. So you could have to go back up to that area 5 or 6 times on a MEP. And some of these buildings are 20, 25 meters high. It's not something that you can quickly get up and down to. So another reason that we decided to get into it is we find that the projects that we're working on are very suitable for this kind of innovation. They're large-scale logistics centres, warehouses, food processing facilities. So you have long linear runs of M&E services. And on the right-hand side there, that's a building we're doing an install at the moment on the UK, and it's half a kilometre long. It's 500 metres long. So if you're using modular MEP systems and you can combine M&E services on the same brackets or modules, or use modular lighting systems, it's a no-brainer. It's going to save you time, it's going to save you money, and it's going to end up with a very nice quality install. Another major benefit for taking a lot of the work off site is the increased safety. So you're undertaking the work in a controlled environment. Construction sites tend to be dangerous enough environments, and if you're in an off-site facility, there's no possibility of weather-related dangers that can be associated with a construction site. You don't have issues where the buildings aren't sealed up, or you don't have wind whizzing through a building site, or you're not dealing with frost or trip hazards or risks from items falling from heights where there be other contractors working in overhead. You're taking away all those safety concerns. Another one is there's less competing with other trades for workspace when the areas of a project become available for trades such as M&E and sprinkler and refrigeration. So what can happen on a lot of the projects we're doing is you're waiting for areas of these huge buildings to become available. So an example of that is you'd have to wait maybe until the concrete floors are poured before you can go in with the MEPs. And that doesn't all happen at once in these large buildings. There's areas, different corners or areas between different grid lines done at every time. But the problem is when an area becomes available, you have M&E contractors, sprinkler contractors, refrigeration contractors. You have multiple trades trying to basically race into that area and make sure they meet the program. So it's dangerous. It gets dangerous if you have a lot of people working to tight deadlines. So again, if you can get a lot of the stuff done off site, you're taking this away out of the project. Another thing is with doing it off-site is the most suitable tools for the tasks, they're permanently installed in a dedicated off-site facility. So in the off-site facility, you've got massive saws and grinders, and everything is there to complete the work, whereas you don't have guys out on site with battery power tools trying to cut through large steel items. It's taken a lot of the danger away. And in an off-site facility, you have your dedicated workstations for assembling and cutting, drilling and welding. So another thing that we find is it really helps with is the project programs and the handover dates. So your large-scale M&E projects, they often need to be completed and handed over to the client within weeks of them going ahead. So having prefabricated M&E services modules ready for dispatch, it reduces the installation time on site. The modules are pre-assembled, so they just need to be lifted into position and connected to the structural elements once they're delivered to site. And this is greatly reducing the on-site labour hours. So again, that's the kind of work there that can be done when I was on about the waiting for the concrete floors to be poured so you could go up and start putting up your services. You're not having those program related issues. If you're assembling these offsite in your facility, you have a lot of that work done, and all you have to do is lift these modules up when you get to site and connect a couple of threaded rods or gripple kits onto structural purlins or structural steels, and that's it, done. So you can be working away on the project and you could be in a different country to the job. So just going to go through how we're doing some of the offsite construction. So we made a large investment into King and Moffatt offsite in Carrick and Shannon because that's where our headquarters is, and a lot of our qualified electricians and fabricators and plumbers and welders are now based in that general area. So what happens is deliver a lot of the modular MEP solutions to the contracting business in Ireland, the UK, and mainland Europe. So we have 40,000 square foot of an offsite prefab facility in Carrick-on-Shannon now, and we just find that it's increasing the speed and the safety and the quality, and it's reducing our carbon footprint. So there's just a couple of images on the right-hand side. You have the facility there. On the right-hand side, that's brackets getting sent out there. A couple of distribution boards there on the bottom right-hand side. Very time-consuming to do that kind of work on site around your distribution boards. So if you've a dedicated facility there in Carrick doing it, it's great. It takes a huge amount of the site hours down. And just a photo there of a delivery getting ready to go out, and a picture from the inside of the facility as well. So we definitely believe that coordination is the key to success if you're going doing any work off-site. We'd be very reluctant to build anything off-site unless there was a huge amount of coordination done before we got to site. So if it's a new build, you need to coordinate with the other stakeholders. So we use BIM, and look, we use Revit to build our models, and we use Navisworks Manage to do the heavy clash detection. We do an element of the clash detection in BIM 360, which flags most of the stuff for us. But just on some of the really complicated jobs, we use Navisworks Manage as well. We try and have the models clash free before we commit to do any offsite work or building any offsite modules. And look, I suppose it's vital that everybody that's installing or bringing something to a project is delivering their job using BIM. So any potential issues can be flagged or before you get to site. There's not much point trying to do this unless everybody's on board, like your sprinkler, your rainwater, siphonic drainage, your refrigeration guys. Everyone has to be on board. It's just an image on the right-hand side. I don't know, you've probably seen it before, but it's just a sample of clash detection in Navisworks and what it might look like when you set up your clash tests. So there's a short video here. The Navisworks and what I talked about there was if there was a new facility. But we do a lot of work on existing buildings, and that means sometimes you're dealing with a couple of CAD drawings, very limited information. And there was a project we did in Dublin once, and the actually only drawings they had on record were drawn by hand from the 1970s. So this is where your laser scanning comes in very, very useful. I know Andy touched on it there on his. He has it there. They're doing it in the course in GMIT, and that is scan of the building. And this is kind of just a quick video to show you how that is done and what the process looks like. Okay, so that's basically going out to site, scanning the facility, and you're left with a point cloud, and that can then be linked into Revit, and you can go and physically build a model of that. And I suppose a huge benefit of that is you're going to know exactly where anything you have to connect onto or hang from. You can identify exactly where it is. If there's any existing if there's any existing services in these areas or in these warehouses or in these seal and voids, you can have coordinated with them. That point cloud can be linked into the model as well. And you can have coordinated with them before you get to site. So it's peace of mind. The last thing you want to be doing when you're doing offsite construction as MEP is having to do it twice, because then you start really losing money. So it needs to be got right the first time. So just an example here of the photo I showed you earlier on with the brackets. Once you've built your families in Revit there, you can get all this information. You can get this back out of the model if you have your schedules set up correctly. So on the left-hand side, this is just an image from the model. And on the right-hand side, it can tell you each bracket type, the lengths of the threaded rods which connect to the structure, the spacings between the different tiers on the brackets, and if there's any other information like an extension onto one side of them, it can all be scheduled out, and this can be sent straight to the offsite facility. Now, we've actually developed this even further in the last couple of months, and I'm going to cover it in a slide that's coming up, and in my opinion, it's even more user-friendly and more streamlined than that. We have tried things like, we have tried plugins to do brackets and stuff like that, but it's we just find this in certain instances it doesn't always snap to where you want it to go, and it's too much risk. If a couple of hundred of these aren't got correct, it can have an impact on program and obviously an impact on cost and everything else. So when you're doing it off site, you can get it just in time and right first time. So there on the left-hand side, that's an assembled module getting ready to be shipped off. And on the right-hand side, that's what it looks like installed in the facility. As you can see, everything, when you have all your Revit models set up, you can align all your runs of containment with the secondary steels or the purlins. And again, there's no hidden issues when you get to site. Everything goes together like a jigsaw. Another thing that we're doing there is you can quickly check the stock levels over in the offsite facility before you send over the combined modules. So this is just to give the people over there an idea if they have to be ordering in more of any type of cable containment or pipe work or duct work. So as the BIM coordinators are developing the models, we have an automatic schedule there and kind of an overall view of the project on a title block sheet. And if they're working away for a few days adding in containment, it literally takes 2 minutes to print a PDF, a revision of this drawing, send it over to offsite, and they can quickly check there. And if they come down and see, oh, there's 1,800 meters, what's that? So that's 200 millimeter data basket. So that's something they might want to go and check. And again, it's no one has to do any extra work to get this information across to them. And the following week they can rev it up and send it across. And just before they send over the information on the 3D modules, at least they're going to know they have the right amount of materials to carry out the task in the offsite facility. So again, brilliant information. It's not information you'll ever receive from doing a 2D job. Like, this is the stuff that we love about BIM. It starts making your workflow very lean. Like, you're down to the millimeter there on the different types of containment that you're using. So another thing we try to do on a lot of the jobs, if we're not building huge modules, is we try to combine M&E services on the one bracket. This has a huge amount of benefits, because on a typical project, your electrical contractors will go out and put up a run of brackets, and you can imagine if a warehouse or a building is 500 meters long, it doesn't make a lot of sense for the mechanical guys to come out and put up another 500 meter run of brackets to carry the pipe work. So you have one team going out putting up all the bracketry, and then the M&E services can be combined on the both. So time and money savings, and just a lovely looking install on site as well when you see everything running together like that. So here's a couple of modules that we're building for a project that we have in pipeline at the moment. this is a client of ours that wants to be doing 80% of their projects off-site within the next 5 years. So we're after spending an awful lot of time developing up this this kind of combined module and the frame over the last couple of months. So this drawing is kind of, it's all of the same area. On the bottom there, that's the frames that are set out within the seal and void. The drawing above it is all your cable containment, and the drawing above it is all the mechanical services. And this is a typical module with everything shown on it. So you have your frame, and you have your combined M&E services. So that's a huge amount of work to be taken off site. Literally, these modules are pre-assembled. You bring them to site. They're 6 meters long. So we've chosen the 6 meters because pipework typically will come in a 6 meter length. And the cable trays typically come in the 3 meter lengths. So 2 of those. And then they're about 2.4 meters wide. So you can't really transport. When you're sending stuff over to the UK or over to Europe, you have to be very mindful about what you can fit onto a lorry or fit through a port or a tunnel. So you don't want to be exceeding 8 meters in length, and you don't want to be going any wider than 3 meters. Otherwise, you're going to end up with huge shipping costs. And that's just a snip from the model there at the moment. So you can see all the frames and how they work. And then you can see the services which are captured within them. So the couple of slides before there, that was a typical module from the center section, a nice busy one showing the M&E services. Another thing that we're building off site there is the mechanical skids. Now this is adding huge quality to them, and again, it's taken a huge amount of work off site. So first thing we do is we detail it up in Revit and make sure the frame is included, because it doesn't float in midair. You just have to go into a heavy level of modeling to make when you are doing stuff off site. There's huge detail required. So we can very quickly check if it's going to fit where we're proposing it to fit on site. And we can also check that there's going to be access around it if any servicing and maintenance has to be done. And then on the right-hand side there, that's what your drawings look like. You have spools and isometric drawings. And it's great information. And again, no more than the brackets and different things. Once you've done this on Revit, you can pull this information out of the model. So typically, some of our fabricators, they would have been working in different companies, and the first thing they had to do when they got an isometric or spool drawn, a lot of the time is they used to have to manually go and measure everything up. But this information is automatically in these Revit schedules, so they don't need to be going to the notebook and the pen and paper. It's all there sitting on the draw in front of them. It's not much extra work for your BIM team to add that information on, and it's invaluable, and really you're eliminating the human error that can often happen. So yeah, it's just look at, obviously, again, when you are doing anything off site, the stuff doesn't float in midair, so you have to design a suitable frame and make sure everything fits inside it, and basically the frame gets lifted up and put onto the truck and brought away. So there's an example of the one of them work in progress there, and there's the 2 of them completed there on the left hand side. So a hot and a cold water mechanical skids, and on the right hand side after it got painted up. So that's a huge amount of work to be taken off site. And again, this was project over in Holland. So you imagine flying these pipe fitters and welders over there to do all this work on site. All they had to do was drive a couple of miles in the road and into Carrick, and that's where that work was done and delivered to Europe. Another one here is, look at if you're doing your automatic schedules again, and that's why the BIM is invaluable again for this kind of information. All of this information on your frame that can be sent over to the offsite, and they don't need to be thinking or measuring or anything. The full cut length is there. the full parts list is there, and they end up just assembling something very easily that's a very nice quality and it's consistent. This is one we talked quickly about. There was a photo of in one of the earlier slides. So there are 2 distribution boards, and again, that it mightn't look like it from the photo, but that trunking, it's called, that containment that's wrapped around those distribution boards, that's extremely time-consuming work to do on site. There's all slots taken out of that trunking on the inside to allow cables in and out, and it's put on a full frame that can be hung up and mounted onto a wall on site. So you'll see there on the left-hand side those uni struts to hold it inside. But another thing that can happen with these is these 90-degree accessories, they're not the off-the-shelf accessories, and the ones that typically arrive on site, they have a chamfer on them, which means this can't be tight around the distribution boards. And again, can look very messy and have an impact on your program on site when wrong stuff starts coming to site. So you're removing the risk and you're keeping the quality very high. So this is what we've done here with the brackets. Is we've basically come up with a naming convention for our brackets, and for all of our BIM modelers, basically it means you can't really go wrong with this. The only ones we want to be manufacturing in offsite, they're the only ones that people have to choose from in our Revit template. And we used to have to do very kind of detailed drawings of the brackets in the past, but we don't have to do that anymore because it's kind of all captured here in our file naming. The type of uni strut, the length of it, the type of a hanger, whether it be a gripple or a threaded rod, and what length it has to be, and then what it's fixing onto. So look, in a warehouse, you might have it fixing onto a purlin. In an office area, it could be fixing into a rib deck. There's other areas where you could be fixing into concrete slabs. So look, at all that's very important when you're doing stuff off-site. There's a lot of stuff to think about. There's no point sending out a couple of 100 brackets or 1,000 brackets if they don't have a purlin connection on them, because then they're just sitting there in a box on site until a couple of 1,000 purlin clamps come out. So again, it's just a lot of coordination and a lot of thought, and then it'll work on site. Another thing that I'd advise is using solutions that are easier to ship and transport where possible. So that image on the right-hand side, they're wire suspension kits. So using these instead of threaded rods, it has huge advantages and benefits when you want to transport items, say from an off-site facility out to the UK or up to a site in Ireland or over to Europe. Threaded rods are extremely bulky to transport. With these gripple systems, it's like a cabling system, and you roll it up into nothing, you know. And you can make very quick adjustments to your uni struts on site if you need to. Whereas if you cut a threaded rod, there's no real, you can't make any quick adjustments on site after that. If you need to make it longer, you have to start looking for threaded rod joiners. Looks very messy. If you need to make it shorter, you have to start cutting it using angle grinders, and then you're going into the use of hotworks permits. So definitely these kind of systems are hugely beneficial. Now, for ELV baskets and cable trays, you probably wouldn't want to be running your submains cable ladders on them for weight and just for pulling cables along afterwards. There'd be too much sway on them. But for other areas where you'd have huge runs of fire alarm and ELV and LV cables, there's no issue. So there's just going to talk about the transportation again here. On the left-hand side there, just to give you an idea. So there's 86 cantilever brackets in the first 2 pallets on the left-hand side, excuse me. But that pallet, the lower pallet in the middle there, there's 500 hangers in that. 2-meter long struts with 5-meter suspension systems. If you had to do 500 of those with that amount of threaded rod on them, it'd probably be the full of the Arctic. Okay. So Yeah, look at these kind of systems can save up to 50% of space in trucks when transporting. And if you have huge drops there, like if you go over 3 meters on a threaded rod, that means you have to get another threaded rod. So if you have a lot of drops there that are 5 meters long, you're gonna have huge weight and huge space taken up in an Arctic truck very, very quickly. Another thing that we're using BIM for is to get very good information back on these linear modular lighting installations, these buzz bar systems. So there's a huge speed increase when you're using a buzz bar system. The lights can be replaced without having to plunge an area into darkness. So with these, you literally put your lights, fix them onto it and plug them in. You don't have to kill a full circuit or a full run of lighting just to do a bit of maintenance on one fitting. You're reducing the amount of cable containment because you're just bringing the containment to one side of this full run, whereas typically on a traditional job, you have to run your containment everywhere where there's lights and wire them all individually. So these kind of systems they're great for offsite and linear and modular electrical installations. You have a lot more flexibility on site as well. When your fittings are hanging there on that buzz bar system, if a client ever wants to change a layout or a racking layout or move something or maybe add a partition or a room in, you can literally move this full run of buzz bar over onto another purlin. It's very flexible. That's just an image of a project there, which will show on the left-hand side. That's what your buzz bar system looks like installed on site. And on the right-hand side, then that's what it looks like then on your model. So again, you'll see there, that's a great example there as well of where you get great visibility of what other contractors are doing when you're using BIM. So again, you'd be doing stuff off-site and running with these kind of systems in a lot more confidence. So I'm just going to talk, I'm nearly finished here now, and I'm just going to talk about some of the benefits that we've realized from doing some of this work off-site and from using our off-site facility. There's a huge saving on travel costs and wasted time associated with travel. So it's not just, I suppose, the time where you're up on the plane, it's going up to the airport and it's getting parked and it's flying over and it's hiring cars on the other side. Like you're taking a huge saving there. You're reducing the carbon footprint. Again, flights are possibly the worst thing for your carbon footprint that you could be doing. So if you can reduce those, you're making a big difference with that. And again, if there's one person going in a van, say anywhere in Ireland, if you can get them doing the work closer to home or in a dedicated offsite facility, you're making a saving there. Huge safety benefits, because the offsite facility, all you have is your own crew in there, and you're not worried about other subcontractors and stuff falling from a height or rushing to get into the same corner of an area when it becomes available, and then rushing the install, which anytime you start rushing, it starts increasing the chance of accidents. Great program benefits. So you have greater control of when equipment arrives to site and less time required for on-site labor as a result of having pre-assembled units and modules. Yeah, and I suppose look at what we've seen last year was certain things that you probably never would have accounted for can have a huge impact on program. Like if for those projects in Germany, or say if Germany was going on the red list and people had to quarantine for a couple of weeks coming back, or if people had to get 3 flights to Germany, like that's if the stuff can still be getting built in an offsite facility, like you're eliminating the risks that can be associated with travel. Now, we never would have thought too much about them until this pandemic came along, but it just kind of opened our eyes into how easily something can come along and have a huge effect on your business. A lot of paperwork was eliminated. So anytime you want to do hot works on site, you have to fill out hot works permits very time consuming, a lot of manual input, and again, if you can have this done off site in your facility, you're taking away a lot of paperwork and admin work on site. There's a huge saving on labour costs, so you haven't got a site team standing around waiting to get access to a certain area of a project when it's ready. You can keep continuing building when you're doing it off site. There's nothing like that happening. You can just go in every morning, start work, and get a good run at it until the end of the day. Saving on materials. You've seen the accuracy of those schedules in Revit. So you're ordering exactly what you need and no more, and you're sending to site what you need. Like years ago there, we used to have to send vans up to jobs when they were finished to bring back where too much stuff has been ordered. They're eliminating all of that now. It's waste. And then you have waste management on site. You're taking all that out of it. It's made certain elements of our workflow much more lean. And another benefit is we find that main contractors and clients, they really love to see this kind of innovation, and they love to see the less work they see being done on site, the happier they tend to be. So.
Hi, Padraic, sorry, just to jump across it. You're finishing up anyway?
Yeah, finished there now.
Good stuff. I'm just conscious of time.
No problem.
Good stuff. So that's a brilliant presentation by Padraic. It's great to see how it's being used. A couple of questions and a couple of comments come in the chat box there. I know I have a few questions for afterwards.
No problem.
But it's great to see how it's being used to benefit you, and how lean you've gotten the process, which is brilliant. So if anybody does have any questions, don't be afraid to ask them in the chat box. I'm going to hand you over to Jaime. So he's going to talk about BIM from a civil contractor's point of view.
Can you see that?
Yeah, we can see that okay, Jaime.
Okay. Good afternoon, everyone. My name is Jaime Mulcair. I'm the company BIM manager for Roadbridge. I have a tough task to try and follow Padraic's there, but I'll try my best. Right, who are Roadbridge? Roadbridge are a multidisciplinary civil engineering company based in, headquartered in Limerick. However, we work throughout the world. We've got jobs in the Nordics, the UK, Ireland. We had some jobs in Qatar and as far away as the South Pacific. So we're 50 years old. We're just over 50 years old now. Our culture is we're a customer-focused, collaborative contractor. We like trying to get out ahead of problems and issues, and this is where BIM, we feel, helps us in delivering this this culture-based approach. Our people then are one of our major assets. They are they are our shop window. They promote our business and enable its performance. And what we're finding is getting people with BIM experience and Civil 3D, etc., is proving vital in how we deliver our projects going forward. We now have a couple of candidates on the GMIT course every year, just trying to upskill our people. We find this course very, very good. So this is some of the experiences and projects that we're working on at the moment. So if you see here up at the top middle, this is the Dublin Port. We are the framework contractor for Dublin Port. This is berth 34, and we're currently working on this berth here, berth 35, which you'll see a model of shortly. Over here on the right is one of the largest wind parks in Ireland, which is Galway Wind Park. Is, I think, soon to be overtaken by Owenini Wind Park, which we're building right now. Again, we're utilizing BIM here, and I'll showcase some of that later on. Just some of the talk about the South Pacific works. So this was a quay construction, which is a tailings pond for a nickel mine. That is 27.5 cubic kilometers of storage or something like that. It's a massive, massive tailings pond. This is a data center for a high-profile client to be unnamed. I think everyone knows who it is. And then this is Dublin Airport. This is the new runway that we're building in conjunction with our JV partner, FCC. Again, we will be showcasing some of the work that we're doing on that. This is a current project and will be delivered later this year. This is one of our road schemes that we did. This is the Gortachune bypass. I was the design manager on this from the contractor for the bid. Big job. Again, use of coordination for design purposes here on this. So this is a nice, simple design by the looks of it. And, you know, what is it? Is it a gas terminal? No, it's a data center. But however, that looks very simple on the upside. But then, just as Padraic explained as an M&E, there's M&E under the ground, but it's civil infrastructure. And this is why it is vital for civil contractors to understand the coordination clash detection associated here. It's the exact same principle as the M&E sector, whereby you want to eliminate clashes, and especially on a very highly complex project like a data center, etc. Because as you can see on the graphic there, 33% of any complex project schedule time is getting it out of the ground. And it is the highest risk part of any project is the actual civil infrastructure part. So this is one of the things that the clients really want to focus in on and get a right first time contractor. So why do Roadbridge need BIM? So why do we need it? We need it for collaboration. We need it for constructability. We need it for control. We need it for continuous improvement. These are our 4 C's. And how do we do that? We, in collaboration, how? We get a business process, which is signed off by BSI or NSAI, whoever you're with. We've recently just got our ISO 19650 transition from our PAS 1192. We still run both. And the reason why is because we have some projects that are on PAS 1192. Why do we want to do it? It's the same as Padraic was saying, create efficiency. We want to try and eliminate waste, do it right first time approach. You know, and who needs this? Again, it's the project team and the end users who are going to be delivering this this project. So what we like to do is do scenario planning with the virtual models, digital twins, etc. So you'll be able to see how things are fitting together. Is there any clashes? What impacts they might have? You optimize the design. This is very important for mass haul, where you're moving an awful lot of material on site, and you want to make sure you're only moving it once, if at all possible. No surprises, less rework. Again, that everything is done correctly the first time. And again, you do it for de-risking projects. You want to de-risk them, and this is a huge problem because, you know, civil infrastructure design and execution is the riskiest part of any element of a build. Why? Because it's, how would I say it? It's the unknown knowns and the known unknowns. So you need to know which one is which. And then when we have things the way we want, and we have our BIM model, or as you want to call it, we operate our machines through machine control. So they're building directly from the model the entire time. And again, we're using data analytics to look at what we're doing right, what we're doing wrong, etc. So project delivery, how do we do it? We have BIM workshops with the clients. We'll begin with the end in mind. Is, you know, asset-centric. What do we have to deliver from an information point of view? So again, the exchange information requirements, asset information requirements. So BIM resources, you look at the supply chain, which is us included. Who's going to deliver it? That means your subcontractors, the main contractor, yourself, etc. The people who are going to deliver it. So are they sufficiently competent enough and trained enough? And then looking at how they're going to deliver it through the BIM execution plan, who's going to deliver it for the responsibility matrix, etc. And then we set up our column and data environment, test and agree our software, our processes, etc. And then you do, the most important thing is you deliver a sample package of data for project delivery to the client to make sure that he's happy with everything that you're trying to achieve. So this is Dublin Port, Port 28. So this was one of our first pilot projects. We did this to try and create a digital twin, what you call it, of the actual project. This is really an asset information model for what we're building to give over to the client, so he's able to check anything off this at any time. So instead of him going through, trundling through maybe 40 folders of information, he can open up this in Navisworks, click on the item element, see all the information that he requires. So this is just a quick video of this BERT 28. So you can see the size of the ship, the size of the port. You can see the piling infrastructure there, the fenders, the bollards. You can see the ladders that go down into the water. You can see the access chambers, the manholes. You can see the lifebuoys. But again, it's only until you get under that you really see the infrastructure that's required. So here you see a big forest of piles that you have to try and coordinate with your utilities and produce and eliminate clashes. And this just gives you an overview of everything there and all the different services that have to come in and out of the model. That was in Revit. The majority of our projects are actually of a linear nature. Therefore, Revit isn't, how would I say it, of much use to a civil contractor, where Civil 3D, on the other hand, is very much so. So we undertook to do another pilot, which was on Bunny Canal and Wind Farm. And we undertook this in conjunction with Malachy Walsh and Partners, and we tried to develop how we were going to deliver it, to try and learn and embed these systems into our processes going forward. And we found this task very, very useful, and to see the limits of Civil 3D, because there is a lot of limits of Civil 3D, and it's, you know, how we can not to over promise what we can do and not deliver on, which was very, very important. Again, as you can see here, this is great stuff for the client to be able to look at. We have this here where you have a hyperlink that you can click on this and it brings you to the documentation in box or a file storage medium. So it's just a hyperlink, but it's brilliant to be able to actually see all the documents readily available in a model. So just to bring you on to some of the projects that we're doing. So this is the NRCP, which is the Dublin Airport North Runway. So we developed an in-house Civil 3D model for all our earthworks and drainage design. As you can see here in this bottom one here, we also developed a geotech model. This geotech model, we were able to model all the strata, etc. So rock levels, clay levels, topsoil, etc., based off the site surveys. And these are the attenuation ponds, etc. And this is our full contour Civil 3D model with relevant earthwork phases associated. And one of the things with the runway construction, people think it's just the runway. It's not. You have the taxiways, but also you have the hardened areas that are off the runway in case there's an incursion by an aircraft. And these all have to be done and done correctly. That means manhole lids have to be at the correct height. They all have to be hardened, etc. So there's a lot of coordination, a lot of design that has to be thought of here. Again, when we have this model, then we were able to do our mass haul calculations. We were actually able to do our machine control files to be able to build the job. So we use machine control extensively here to do a right time first approach, etc. So here, this is one of the data centers that we're working on. You can see one of the Navisworks models here. And these are our Civil 3D models that we generated. So again, we were using these for earthworks and for the general landscaping and for forming of the landscaping bunds, etc., to make it look nice and pretty. This allowed Roadbridge to accurately execute these works with the right first time approach. Again, we have the M&E and the drainage and all the services that are installed associated with this in this model also. So this is Dublin Port Ocean Pier BERT 35. This is currently on site. This was one of the animations that we got done to showcase to the client how we were going to build the project and to the level of detail that, to help people understand how we're going to build it, the sequence and the timing associated. And then we have a Revit model, which we were able to pull quantities off, schedules, etc., and be able to just take it apart and see what we could bring offsite from a modular point of view. So I think if people have been on LinkedIn, they would have seen Midland Steel. They did a a very big sequence here where they actually we offsite fabricated the rebar for the coping beam here. That was brought on site, poured, everything done within a week, which was fantastic, and it was a great use of MMD by Roadbridge. This is another project again. Dalwar bypass. We had a 250-meter steel viaduct over the River Garnock and Glasgow railway line. So this is the Revit model here, as you can see, and this was one of the visualizations of that model. And these was fabricated by our contractor Moffatt Building, totally off-site, brought to site, welded, and then just launched. Here you can see some of the lovely work that we're doing on our wind farm for our wind farm project. So this one is in Scotland. So we designed the road networks in Civil 3D. How we have our own design houses that we use, but sometimes we'd like to take this in-house to optimize earthworks and micrositing, etc., because it has to be very fluid with the way that you can microsite both roads and turbine bases. It de-risks the project because you are able to identify what's the optimum route for a peat depth point of view, from a rock level, clay issue, etc. And then we utilize both the model for both setting out purposes and for machine control. Again, we use the Geotech module in Civil 3D for modeling the strata. So some of the digital tools that we use Bluebeam for doing our takeoffs, etc. We find this very, very good. We sometimes use Bluebeam Studio for our collaboration. I find that a very good medium. We have a CDE, we have a company CDE. We also use our own document management system, and we've utilized multiple ones. However, we find that trying to keep it very simple and very lean is always the best. Again, we've used, this is a project that we priced over in Greenland. This is the new runway that they're building there. We priced the earthworks associated. So this gave us a very good sight into just doing rough calculations, etc., without having a civil 3D model up front. This is one of the digital tools we also use. It's time change modeling. This is very complicated, but a very effective tool. And what it does is it links your program with your sequencing, with your quantities, with your timeline, with your activities, and your mass haul. And so it's a massively beneficial tool. This is your whole project and how you're going to build it on one page. And it's a great graphical representation of how you're going to build it and what sequences are ongoing at any one time. It's a very visual medium, and it really communicates to their team what's happening once you get into the nuts and bolts of it. So from a software and a survey point of view, we've invested heavily in trying to utilize BIM, which call out inside, where we have our loggers now, where you're able to open models directly on the loggers, as you can see here on this one. We've also used, authoring software, design review software, but we're also using scanners as well. So this was the Dublin Airport runway. We use a scanner there for modeling or for doing quality control on the subbase and pavement quality concrete. Here's another one, which is Trimble Site Vision, which we're using as well for what we're doing is we're inputting our existing survey data into it. So when the guys go out and do their marking up for the surveys prior to doing digs, etc., that we know exactly what's in the ground. So machine control, we've done a massive investment in machine control, and we've one of the largest in-house plant fleets in Ireland and the UK. We've predominantly all our machines are machine control that are required. So as you can see here, this is one of the projects. There was an attenuation pond. You can see the attenuation tank at the back. So this was the model with the stepped battered finish. You can see the stepped battered finish. So this is directly following the model. This is another one now that BOMAG on HS2 project that we're working on at the moment. We can see the passes. So this is geolocated data of how many passes went on in each over each area, and that's like a heat map kind of thing. And again, we're into the hybrid technology, the latest hybrid technology. To try and reduce fuel costs, carbon footprint, etc. And here's this is on the Dublin Airport project where we're putting out the sub base with GPS, etc. So one of the things that we're really looking into is the machine, our fleet analytics. So again, from what's producing what's the fuel usage, etc., carbon footprint. So we run an ISO 50001 system. So we have to do reports on all energy uses, etc., which plant and our vehicle fleet make up an awful lot of it. So again, you can use a lot of things here, and it's a great mechanism for us to analyze where we can make savings. So again, you can use GPS tracking data for heavy braking, speeding, driving styles, so you can do driving training programs, etc. One other thing, sorry, I just wanted to go back on here, machine analytics, is Dublin Airport asked us, we had our compound right beside a live runway. They asked, I think everybody saw that one where the mini digger went into the travel lodge and decided to rip up the entire place, and they got scared over this, and they wanted to understand how we could stop that. So you can geofence your machines that basically that they can't go outside another a certain area, otherwise they turn off automatically. So that was a very, very good system. And then we want to understand our health and safety and quality analytics. So this is vitally important to understand how we're performing from a health, safety, environment and quality point of view. We wanted to have real-time statistics. We wanted to have track leading indicators. So we wanted to understand what is going to potentially happen, how do we change it, etc., and do trend analysis based off that. So again, we wanted to use the right data to get the right result. And here's a very, very good one. I don't know, do you know about this one? But this is the Navy and the Air Force were bombing Germany, and they decided to find out how, which they wanted to do an analysis of why they were losing so many bombers, and they wanted to up-armor them. So they said, they did this analysis, and they said, this is where all the bullet holes were. And they said, okay, we need to up-armor the wings and the tail section. And this fella goes, yeah, but you're looking at the wrong data set, because the right data set are the ones that didn't come home are the ones that got hit where there was no bullet holes, which is the engines and the cockpit and the middle tail section. So we have to make sure that we're always looking at the right sample set of data. Again, so BIM, what does it mean for civil contractors going forward? One of the things that you'll see here now is Volvo and Komatsu are trialing AI-assisted cameras on their quarry trucks, etc. So you can see this is an automated quarry truck they're trialing at the moment. This is an automated scanning dog. I can't remember Boston Scientific. I can't remember his name now. It could be Bosco or something. I'm not too sure. But he goes around, scans buildings. Here you're using augmented reality and to see how a beam might look in instance. And as you can do the exact same with duct networks and etc. There's actually a very good thing there on augmented reality for underground services that we will be looking at very shortly. Here you'll see also is Highways England. They ran a trial on an autonomous dump trucks. So you can see there's no driver there. There's a guy now in the passenger seat because he's just making sure that nothing happens. But this is all fully autonomous, and they just ran that trial. And Highways England are pushing the research of this a lot to try and automate this. Times are changing, and BIM it's laying the groundwork. So what ISO 19650 has done now is laid the framework for this, and this will be built on over the coming years. So in conclusion, BIM for us, it's a tool that increases our efficiency, it lowers our risk profile and promotes collaboration, but it doesn't build anything. We still have to get out and build it and get our boots dirty. But what it does is it eliminates mistakes. It will speed up production. And again, the other thing there is that, it's at the forefront. Is using the latest software, the latest technology in the industry as well. So it's at the forefront of the digitization of civil engineering. That's it.
That was great, Jaime. Brilliant to see how it's being used within the real world context. So we're going to finish up the presentations now and just go through any questions that people may have. Just looking through the chat box here. So John Hill has mentioned that they're working on a project where they have modular pipe bridges, but they also have the scaffolding set up on them. This is during Porg's presentation. He mentioned it, which is pretty interesting, that they're lifting up the scaffolding and the pipe bridge together up to 10 meters, and the scaffolding is there ready to go. And one question I have for Porg is, how do you keep track of all of those essentially pieces of the puzzle that go together to make to build your components? And when they get to site, are you barcoding them, or are they just numbered, or how are you keeping track of all that?
No, we're tagging them. We're tagging them. So rather than tagging a piece of containment or a piece of ductwork that's on the module, Andy, we tag the actual module, and all the detail is added to the modules drawn. When they get to site, I don't know if you noticed the drawing, but there's kind of we were using hatched areas to show where each module was going on kind of a key plan. And okay. the modules are tagged. So that's why when the module goes to site, they know where to put that module. But the drawing would be far too cluttered if you're trying to put all the information of everything that was on the module onto a drawing for the site team. That if they had to check back on anything, they could refer back to the unique drawing for each module, which was kind of the drawing that had the 3D module, and then all the pipe work inside that tagged, and the buzz bar and the cable trays and the ductwork.
Yeah, that's brilliant, because I can imagine if that wasn't done correctly, how messy it could get and how quickly that could happen.
No, it'd be very messy. And what we're doing there now is we have a unit there. I know you're familiar with it. It's kind of like a scanner, except it uses infrared. It's the Matterport. And what we're doing is every time a module is built, we're scanning it, and it has two purposes there. So we can take the MatterPack scan and bring it back into the model and double check that everything is exactly how it has been modeled. But you can also send the web link out to your main contractor and client, and they get great peace of mind because they know all the work. Sometimes they think, God, there's no one on site here, is any work being done? But when you're able to share out a link to something as simple to use as the Matterport scanner, it just gives them great reassurance that they can see all this work. Everything's been built off site, and they can go in and have a great look around it. And it's helping us with the quality and checking, and it's also great to share out as each module has been developed.
Are you finding it's as accurate as using a laser scanner? I know it's a lot quicker. Does it have the same accuracy?
It's a lot quicker, and look, we've only been using it there for the last couple of months, but it seems to be pretty good. I haven't noticed any major differences, and it looks good when it gives enough detail to see exactly what's going on when it's linked into Revit. I don't know if it will be as accurate at longer distances, but we set the scanner up very close to the modules and move it around so it can get every corner of it.
Yeah, that's brilliant. John Hill has just clarified there, for the project he was talking about, they're actually using barcodes to keep track of, even down to individual pipes. So it's interesting to see the two kind of methodologies as to how you keep track of them. I have one question actually first for Jaime there. You're talking about the machine control for your equipment. Mm-hmm. How much of that is machine controlled and how much is human?
Oh, yeah. I mean, it depends. So, there's different types of machine control. You can have fully autonomous machine control, which basically, you can move the levers as much as you want down, but they won't go down. And that's the newest version. We have I think we have around 5 machines of that, but the majority of them have to follow, you have a screen and you have to try and follow that line, and keep it in that line. So there is still very much driver skill is still in it. However, what we're seeing is it's just the productivity is huge. But one of the things that we're seeing also is that being able to use, just like the geofence, if you're in a model, if you have a fully autonomous system, you can put a box around something so you can enable people to not dig in that area. So that's vital. Say if you had a gas pipeline that was crossing your site and you wanted to make sure that no one's going to dig there. But again, there's, that's great for the machines that have machine control, but when some other machines don't, you just can't rely on that. So that's why you have to try and put the best thing forward that you can. But yes, what we're finding is that, you know, a lot of people don't want to drive machines anymore. There's a lot of that. So I do believe having full machine control soon will help a lot of people to both develop skills, and then when they get a bit more comfortable, they mightn't need it as much. But it is. I think it's great to have it. I think that we still need to develop the skills of our drivers, etc. Though, I think that's vital. It's training, etc. too. You know.
Yeah, that's brilliant. I'm assuming that, say you have an excavator, it's kitted out with a couple of GPS units. It knows exactly where it is, and it knows where it needs to stay away from. Like you talking about geofencing off a gas pipe.
Yeah, you know, I mean, like, you know, it's all inbuilt. So they come with the GPS ready, but what kit you put on that? So there's multiple suppliers out there that you can go to. So yeah, you can put on whichever, and then it's what option list you pick associated with this. So I mean, you know, the newer versions now, you can have full autonomous control, which basically means, you know, I could drive it, you know, whereas compared to somebody else. Then you can also have other systems there. You know, we have ones lift restriction. So and slew restrictors on them as well. So if you were doing a job beside a live motorway and you don't want the machine to slew out onto traffic, you can put a restrictor on that machine to stop the slewing out there, which is very, very good. You can also do vice versa from underground. If you have overhead cables, you can actually do a box for that cable upwards as well. So the machine won't be allowed to go into that area with the boom up, etc. So it's very, very good for striking, for service strike prevention. There's also other innovations that are coming down the line where they're using active scanning from cameras, onboard cameras, to detect people approaching and to warn the driver. So, you know, getting hit by a machine, etc. That's a big one. So your blind spot, you know, you can see it in the car, but it's even worse in the machine. Like we have some machines with 80-ton excavators. There's a fair big blind spot on them, and you know, you don't want to approach them until, you know, whereas these active systems now, which are going to be coming into force, they'll be huge going forward from a safety point of view, especially on a congested site. So say a data center, etc., where you have a lot of people on the ground who might not be your you know, in your works area or whatever, but you know, it's definitely a positive going forward.
No, that's brilliant. I think it's probably something that you'll always need a competent individual controlling it, but it's there to make their life easier and more efficient, rather than being this
the evil replacement. Evil replacement.
No, that's brilliant, and it's great to see how it's being used in there and fairly locally too. You know, in and around Ireland. Sometimes I think all too much we see these case studies from sites that are probably a lot bigger than ones that we're used to. That it seems kind of some of the technology almost seems far fetched.
I mean, like,
but it's great to see how it's been used with local companies.
Oh, very much so. I mean, like, you know, it's brilliant. I mean, like, you know, there's anybody can use BIM. There's a guy over in Sweden. He's one of the biggest proponents of BIM and earthworks modeling, etc. And he's completely bought into it. And he's you know, he was a one-man band. He now has 40 guys working for him. And he started off doing the exact same thing, you know, doing lean workflows, how to present, but he's just doing housing developments. You know, so I think it's going to be huge going forward in the industry.
Yeah, no, most definitely, and that's brilliant. Padraic and Jaime, I'd like to thank you for your time and your presentations. They were extremely interesting.
No problem.
So I thank everyone for joining us. Susan, do you want to say a few words before we finish? Suzanne, sorry.
I just want to say thank you to everyone. That was a great the presentations were super, and great attendance and everyone. There's a good few questions there, so it's great to see so much interest still in the regions, and we've got 4 days still to go, which is super. So anyone else who's interested in the future regional weeks, which hopefully we might be able to do them face to face, but if not, anyone else interested in presenting and being involved, please just send an email through to Shannon, admin@cita.e. Thanks again. I hope you're able to come on for the rest of the week. They will all be recorded anyway, and you'll be able to get the links to those recordings if you're on the MailChimp database. So if you're not on that, just send an email through to admin@cita.ie and we can make sure that you're able to subscribe to that. So thanks a million.
Thanks, Suzanne.
Take care.